Welcome to the class of medical physics. In the previous lecture, we have discussed about the laws of reflection of light, the laws of refraction of light, the total internal reflection, its associated Snell's law. In today's lecture, we are going to discuss about the law of absorption of light. Okay, law of absorption. Absorption in wave motion is basically the transfer of energy of a wave to the matter as the wave passes through that matter. That how much that wave form is being, that wave motion or that wave energy is being absorbed by any medium, any matter through which that wave is passing. That is known as absorption and associated with law of absorption. The energy of an acoustic, electromagnetic, or any other wave is proportional to the square of its amplitude. And as the wave passes through a substance, that amplitude decreases gradually. So it says that whatever the type or whatever the nature of your wave is, whether it is acoustic sound wave or electromagnetic wave or any other medium of any other sort of transfer of energy, if it is passing through a substance, through a material, through a matter, its intensity decreases gradually. By what extent? By which is proportional to the square of its amplitude. By that measurement, square of the amplitude of the wave, its amplitude decreases gradually. Absorption of electromagnetic radiation is defined as how matter takes up a photon's energy and then transform that energy, whether it is electromagnetic energy, for instance, into its internal energy of the substance or internal energy of the absorbing medium. For example, the thermal energy. Most of the time, it happens like uh, any any sort of energy, any type of energy, whether it is electrical energy, radio, electromagnetic radiation, or sound energy, they ended up as a thermal energy. It generates heat and it emits heat as the end product, as the end results. So, we as we are talking about, we are discussing it in the section of light, so we are supposed to particularly stick to electromagnetic radiation. In this picture you can see that there is a medium, a change in medium from air to solid, air to liquid, in which the incident light is passing through that medium from air medium to the liquid medium and then back to the air medium. So you can see the intensity of this incident light, which is I naught, just before entering into the liquid medium, is being absorbed by that liquid medium to some extent. By how much ratio? By the square of its amplitude of light, right? So by that extent, the portion or the amount of light is being absorbed by that liquid medium, and then the remaining light, which is known as the transmitted light, is being re-emitted from that again back into the air. So it depends upon the time the light is has to be remain in the liquid medium, or the length or width of that medium. There are two factors of that absorption. One is width and another one is time, like through how much width the light has to be covered in the next medium, which is fluid in this case, for instance, and till how much time it will take. That will increase or decrease the absorption rate of the light. If there is only a small fractional absorption of energy, the medium is said to be transparent to that particular radiation. But if all the energy is lost, that medium is said to be opaque. What does it means? It means that if we see in real life objects, few objects appear to be as transparent, whereas appear to be translucent or opaque, for instance. So the transparent materials or the transparent medium appears to be transparent because the absorption of energy of light to that, to those particular medium which are appearing to be as a transparent, that their absorption of light is very small. That is why they appear to be as transparent. However, opaque materials just because they have tendency to absorb much amount of light, or the you can say the most of the light energy, or all the energy is lost, right? So if all the energy is lost, that medium is denoted or appeared to be as opaque. This is all because of the absorption of light. We can see some objects as transparent and others as opaque. We can differentiate. Next, however, all known transparent substances show absorption to some extent. They do have absorption of light. It completely doesn't mean that transparent objects don't even absorb any portion of light, but they absorb a small fractional portion of light. So they have certain absorption. For instance, you have an example of ocean, that the ocean appears to be transparent to sunlight at the top of the surface, the outermost layer of the ocean, but it becomes opaque with depth. As you can see in this picture, it is again one complete picture of law of reflection and law of refraction of light. For example, just assume this arrowhead as the incoming sunlight, as incident light, which is reflecting back into your eye with the same, with following the law of reflection of which says that incident angle is equals to reflected angle. So if you just draw a normal over here, you will find out that angle of incidence is completely equal to angle of reflection in this case as well. As we have discussed in previous lectures, that whenever light hits a medium, light hits a surface, it reflects back with the same angle, whereas certain amount of light is being passed on to the next medium and known as the refracted or the transmitted light, but with different angle to the angle of incidence. So in this case, if you can see, sunlight is coming from air and entering into the ocean. So there is a shift in medium, a change in medium, and the next medium, which is water, is more dense or highly dense as compared to the air. So the refracted light is going to be decreased in angle with the normal. If you just draw a normal over here, the angle you will find will be a decreased in measurement as compared to that of incident light, which again clears your Snell's law, which says that when light enters from a light density medium to a higher dense medium, its angle of refraction is going to be decrease as compared to the angle of incidence. Okay, this was all about the law of refraction and reflection of light. Here we are talking about the absorption of that light. So as this indicates, as it says that the ocean appears to be transparent to sunlight near the surface, but it becomes opaque with the depth. This happens because the top layer or surface of ocean is going to be absorb some fractional amount of light again. But with increase in depth, as you go in the deep, the light is being more and more absorbed by each and every layer. So till the end of the ocean or the bottom of the ocean, the light is going to be absorbed at the most. And hence it appears that as opaque or dark in the depth. Next, substances are relatively absorbing. All the substances, all the matter, all the things which are present in your surrounding are selectively absorbing. That is, they absorb radiation of a specific wavelength. It means if you have capability to differentiate one object with another in terms of their size, their mass, their shape, and of course their colors. So you can identify, you can differentiate any object with other. If in terms of color, it means that they have selectively absorbance of light. Different color has different rate of absorption of light according to their wavelength. What does it mean? It means, for example, if you take an example of grass, grass is transparent to green light. It means grass is not going to be absorbed the green wavelength of light, but opaque to other colors, any other color, the red, the blue, the violet, the yellow, orange, any other color. So your eyes can differentiate a green surface, whether it is a grass, it is a leaf, with any other object, any other particular thing in terms of their color. You see, you observe the leaf, the surface of leaf as green because the incoming light, which is white in color, coming from the sun, for example, contains all seven wavelength of lights, right? But the leaf, that particular material has have tendency to absorb all other colors, and it appears to be opaque for all other colors of wavelength of light, but not for green. For green color, it is going to be appear as transparent. That is why the green wavelength of light is not going to be absorbed by this surface of leaf and is going to be reflected into your eye only the green color, the wavelength of green color. That is why our eyes differentiate that particular color as green. If it is differentiating it as green color, it means that light is not absorbing that particular wavelength, but it is absorbing all other wavelengths of light. That is why you can easily differentiate the green color with rest of the colors. Similarly, in the next example of red, we can see the red object has tendency to absorb rest of the color, but it will reflect the red color, which is going to be reflected into your eye, and you can easily differentiate the object as red because the red light wavelength is not being absorbed by that red material, or the red material is transparent for red wavelength of light, but it is opaque for rest of the colors. That is why the rest of the colors are being absorbed by the material, and you can only identify this object as red. Or for instance, the if you have the leaves on the top, if it is green, it is not going to be absorbed the green color. It is transparent to green color. That is why you can differentiate it as green. So the bottom line is that different objects have different tendency to absorb a particular wavelength of light. If it is going to be absorb any particular wavelength of light, it is going to be reflect rest of the light or rest of the wavelength, which is going to be uh, identify as that particular color of that object. Clear? Next is the inverse square law. What is the inverse square law? This law states that the intensity of an effect such as illumination or gravitational force changes in inverse proportion to the square of the distance from the source. It says that any sort of intensity of any source, whether it is illumination of light, it is gravitational force, it is going to be decreased. Its intensity is going to be decreased if you go away from that source with a square of the distance, right? So in other terms, the intensity of illumination of the point is inversely proportional to the square of the distance from the source. It indicates by the formula that intensity is directly proportional with inverse of the square of the distance from the source. So intensity of illumination, which is denoted by I in any given direction, whereas R is the radius from the point source. So as you can see in this picture, you have a circular point source, for example, and it is emitting any sort of energy, whether it is gravitational force, it is a light source, so it is going to be disperse of light in each and every direction 360 degree around, right? So its intensity is illuminating and going to be decreased with a square of the distance with from the point source. This picture is going to be present you a much more better clear picture of this phenomena of inverse square law. Like, you have a point source, it is illuminating any sort of energy, a gravitational force. This could be a light source, light waves, waveforms, or any sort of energy. So the intensity of that energy is going to be decreased with a square of the distance. For example, if you just notice, you have that one particular A4 sheet, for example, and it is spotting 1, 2, 3, 4, 5, 6, 7, 8, 9 spots, for example. Just for example, if it is spotting nine light rays, or any force at 9 spots, if you just go square of the distance away from that particular area, you will notice that all those 9 spots are being dispersed far away. So this is why the intensity on paper, for example, this A4 paper, which is written A, which was collecting 9 rays at this point, at this distance of r from the source, at the distance of 2r, that particular paper piece of paper is going to spot only 3 of them from the 9 out of 9. If you just go far away from that source, again with the square of the distance, so that similar piece of a paper is spotting now only one ray. It is collecting or receiving only one ray from that 3. So you can say the rest of the whole 9 rays are there, but they are being dispersed. So the intensity absorbed by that similar piece of a paper, size of piece of a paper, the intensity received by this paper is being reduced due to the distance away from the source. So this is the inverse square law, and uh, it it is for all type of energy transfer. You could be for it could be for gravitational force, for light intensity. The basic concept is that if you go far away from the source, the intensity of that particular source is going to be decreased with the passage of distance, right? So this is all up to the inverse square law. See you in the next lecture. See you in the next lecture. Thank you.